When connecting ground fault interrupter receptacles in a small appliance branch circuit, several factors must be considered to ensure safety and reliability. Firstly, the method of connecting the receptacles themselves is important. Daisy chaining receptacles using the side screw connections is generally not recommended. This is because it can create loose connections, and these loose connections can lead to safety hazards such as arcing and overheating. Pigtails offer a much more secure and reliable connection method. Using pigtails is highly recommended for connecting all receptacles in a branch circuit. Pigtails involve using short lengths of wire to connect the receptacle to the main circuit wires via wire nuts. This creates a more robust and dependable connection. Now, regarding wire length requirements, Section 300.14 of the National Electrical Code, or NEC, does address wire length but does not specifically dictate the length of wires connected by a wire nut in a small appliance branch circuit. However, adhering to good electrical practice is essential. All wires within the electrical box should be trimmed to a reasonable length. A typical recommendation is to keep these wires to 6 inches or less. This minimizes clutter within the box and helps ensure proper connections. The pigtails that connect the receptacle screws to the wire nut should also be kept to minimum length. A practical range for these pigtails is typically between 1 and 2 inches. This provides enough length for secure connections without creating excessive wire within the box. To ensure a safe and reliable connection, consider these steps. 1. Use ground fault interrupter receptacles with pigtails for both the neutral and hot wires. 2. Connect the pigtails to a wire nut along with all the other branch circuit wires. When doing this, trim the wires to a reasonable length, generally 6 inches or less, to maintain a neat and manageable connection. 3. Connect the pigtails from the ground fault interrupter receptacle to the side screw terminals of the next receptacle in the circuit. 4. Repeat steps 2 and 3 for all the ground fault interrupter receptacles in the branch circuit to ensure consistency and reliability throughout the entire circuit. 5. It is extremely important to ensure that all connections are tight and secure. Loose connections can lead to arcing, overheating, and potential fire hazards. Regularly inspect and tighten connections as part of routine maintenance. In summary, when working with ground fault interrupter receptacles in small appliance branch circuits, prioritize safety and reliability. Avoid daisy chaining through side screw connections. Use pigtails for secure connections. Maintain reasonable wire lengths, typically 6 inches or less for wires connected by wire nuts and 1 to 2 inches for pigtails. Follow the recommended steps for connecting the receptacles and always ensure that all connections are tight and secure. Proper adherence to these practices will help maintain a safe and functional electrical system. Ground fault interrupter receptacles are crucial safety devices designed to protect against electrical shock. They work by monitoring the current flowing into and out of a circuit. If there is an imbalance, even a very small one, it indicates that some of the current is leaking to ground, possibly through a person. The ground fault interrupter receptacle quickly trips the circuit, cutting off the power and preventing a potentially fatal shock. These receptacles are commonly installed in areas where water is present, such as bathrooms, kitchens, and outdoor locations, because the risk of electrical shock is higher in wet environments. Regular testing of ground fault interrupter receptacles is important to ensure they are functioning correctly. Most ground fault interrupter receptacles have test and reset buttons. Pressing the test button should cause the receptacle to trip, cutting off power to the circuit. The reset button can then be used to restore power. If a ground fault interrupter receptacle does not trip when the test button is pressed, it should be replaced immediately. When selecting ground fault interrupter receptacles for small appliance branch circuit, it is important to choose devices that are rated for the appropriate voltage and amperage. Most residential circuits are either 120 volts or 240 volts, and the receptacle should be rated accordingly. The amperage rating should also match the circuit breaker protecting the circuit. It is also important to consider the specific needs of the appliances that will be used on the circuit. Some appliances, such as refrigerators and freezers, require a dedicated circuit to ensure they receive a stable power supply. Other appliances, such as toasters and coffee makers, can be used on a general-purpose small appliance branch circuit. When installing ground fault interrupter receptacles, it is essential to follow all applicable electrical codes and regulations. This includes the National Electrical Code, as well as any local codes that may be in effect. These codes provide detailed requirements for wiring methods, grounding, and overcurrent protection. Working with electricity can be dangerous, and it is always recommended to consult with a qualified electrician if you are unsure about any aspect of the installation. A professional electrician can ensure that the work is done safely and correctly, and that the electrical system is in compliance with all applicable codes. Proper grounding is a critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and cut off the power. Without proper grounding, fault current can flow through unintended paths, such as through a person, causing an electrical shock. Grounding is typically achieved by connecting the metal enclosures of electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode is then connected to the neutral conductor at the service entrance. This creates a low impedance path for fault current to flow back to the source. The size of the grounding conductor is determined by the size of the circuit conductors. The National Electrical Code provides tables that specify the minimum size of grounding conductors for various circuit sizes. It is important to use the correct size grounding conductor to ensure that it can safely carry the fault current. In addition to grounding, bonding is also important for electrical safety. Bonding involves connecting all metal parts of an electrical system together to create a continuous electrical path. This helps to equalize the voltage potential between different metal parts, reducing the risk of electrical shock. Bonding is typically achieved by using bonding jumpers to connect metal enclosures, raceways, and other metal parts. The size of the bonding jumpers is determined by the size of the circuit conductors. The National Electrical Code provides tables that specify the minimum size of bonding jumpers for various circuit sizes. It is important to use the correct size bonding jumpers to ensure that they can safely carry the fault current. Overcurrent protection is another essential aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current flow. When the current in a circuit exceeds the rated capacity of the overcurrent protection device, the device will trip, cutting off the power to the circuit. This prevents the wires from overheating and potentially causing a fire. Circuit breakers and fuses are rated in amps, which is a measure of the amount of current they can carry. The size of the overcurrent protection device should be matched to the size of the circuit conductors. The National Electrical Code provides tables that specify the maximum size of overcurrent protection devices for various circuit sizes. It is important to use the correct size overcurrent protection device to ensure that the circuit is properly protected. Arc fault circuit interrupters, also known as arc fault circuit interrupter breakers, are another type of safety device that can be used in electrical circuits. Arc fault circuit interrupter breakers are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur when electricity jumps between two conductors, creating a spark. These sparks can ignite flammable materials, such as wood or paper, causing a fire. Arc fault circuit interrupter breakers are able to distinguish between normal arcs, such as those that occur when a switch is turned on or off, and dangerous arc faults. When an arc fault circuit interrupter breaker detects a dangerous arc fault, it will trip, cutting off the power to the circuit. Arc fault circuit interrupter breakers are required in many areas of the home, such as bedrooms and living rooms, to provide enhanced protection against electrical fires. When working with electrical circuits, it is important to use the proper tools and equipment. This includes insulated screwdrivers, pliers, and wire strippers. Insulated tools are designed to protect you from electrical shock. It is also important to wear safety glasses to protect your eyes from flying debris. Before working on any electrical circuit, it is essential to turn off the power to the circuit at the circuit breaker. This will prevent you from getting an electrical shock. It is also important to test the circuit to make sure that the power is off before you start working on it. You can use a voltage tester to check for voltage in the circuit. If the voltage tester indicates that there is voltage present, do not work on the circuit. There are several different types of wire connectors that can be used to connect wires together. Wire connectors are designed to provide a secure and reliable electrical connection. The most common type of wire connector is the wire nut. Wire nuts are plastic caps that screw onto the ends of wires, holding them together. Wire nuts are available in different sizes to accommodate different numbers and sizes of wires. Another type of wire connector is the push-in connector. Push-in connectors are small plastic devices that allow you to quickly and easily connect wires together. To use a push-in connector, simply strip the insulation from the end of the wire and push it into the connector. The connector will automatically grip the wire, creating a secure connection. Screw terminals are another common way to connect wires. Screw terminals are found on many electrical devices, such as receptacles, switches, and light fixtures. To connect a wire to a screw terminal, simply strip the insulation from the end of the wire and wrap it around the screw terminal in a clockwise direction. Then tighten the screw to secure the wire. When connecting wires together, it is important to make sure that the connections are tight and secure. Loose connections can cause arcing, overheating, and potential fire hazards. After you have made the connections, tug on the wires to make sure that they are securely connected. If the wires come loose, tighten the connections or use a different type of wire connector. When working with electrical circuits, it is also important to be aware of the different types of wires that are used. The most common type of wire is non-metallic sheath cable, also known as Romex. Romex is a type of electrical cable that consists of two or more insulated wires encased in a plastic sheath. Romex is typically used for residential wiring. Another type of wire is armored cable, also known as BX. Armored cable is a type of electrical cable that consists of insulated wires encased in a flexible metal conduit. Armored cable is typically used in commercial and industrial applications. Conduit is a metal or plastic pipe that is used to protect electrical wires. Conduit is typically used in exposed locations where the wires could be damaged. There are several different types of conduit, including rigid metal conduit, electrical metallic tubing, and flexible metal conduit. When installing electrical wiring, it is important to follow all applicable electrical codes and regulations. This includes the National Electrical Code, as well as any local codes that may be in effect. These codes provide detailed requirements for wiring methods, grounding, and overcurrent protection. Working with electricity can be dangerous, and it is always recommended to consult with a qualified electrician if you are unsure about any aspect of the installation. A professional electrician can ensure that the work is done safely and correctly, and that the electrical system is in compliance with all applicable codes. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. The NEC is not a law, but it is often adopted by state and local governments as part of their building codes. Compliance with the NEC is essential for ensuring the safety of electrical systems. The NEC provides detailed requirements for the installation of electrical wiring and equipment. These requirements are based on years of experience and research, and they are designed to minimize the risk of electrical shock and fire. The NEC also provides guidance on the proper selection and use of electrical equipment. This guidance is designed to ensure that electrical equipment is used safely and effectively. The NEC is a valuable resource for electricians, contractors, and homeowners. By following the NEC, you can help to ensure the safety of electrical systems. Ground fault circuit interrupters are designed to protect people from electrical shock. They work by monitoring the current flowing into and out of a circuit. If there is an imbalance, even a very small one, it indicates that some of the current is leaking to ground, possibly through a person. The ground fault circuit interrupter quickly trips the circuit, cutting off the power and preventing a potentially fatal shock. Arc fault circuit interrupters are designed to protect against electrical fires. They work by detecting arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur when electricity jumps between two conductors, creating a spark. These sparks can ignite flammable materials, such as wood or paper, causing a fire. The National Electrical Code requires the use of arc fault circuit interrupters in many areas of the home, such as bedrooms and living rooms. This is because these areas are more likely to contain flammable materials. By installing arc fault circuit interrupters, you can help to protect your home and family from electrical fires. There are several different types of electrical boxes that are used in electrical wiring. Electrical boxes are used to enclose electrical connections and protect them from damage. The most common type of electrical box is the metal box. Metal boxes are typically used for surface-mounted wiring. Another type of electrical box is the plastic box. Plastic boxes are typically used for recessed wiring. There are also several different types of specialty electrical boxes, such as weatherproof boxes and explosion-proof boxes. Weatherproof boxes are used in outdoor locations where the box could be exposed to the elements. Explosion-proof boxes are used in hazardous locations where there is a risk of explosion. When selecting an electrical box, it is important to choose a box that is appropriate for the application. The box should be large enough to accommodate the wires and devices that will be installed in it. The box should also be made of a material that is suitable for the environment in which it will be used. When installing an electrical box, it is important to follow all applicable electrical codes and regulations. This includes the National Electrical Code, as well as any local codes that may be in effect. These codes provide detailed requirements for the installation of electrical boxes. Working with electricity can be dangerous, and it is always recommended to consult with a qualified electrician if you are unsure about any aspect of the installation. A professional electrician can ensure that the work is done safely and correctly, and that the electrical system is in compliance with all applicable codes.